Hello everyone, this is Pradeep Salunke with my project partner Ashish Patel, and today we are going to discuss about lathe tailstock. So these are the project outline we are going to discuss: project background, design parts, design assembly, manufacturing of spindle bearing, DFM, DFA, redesign of parts, and summary. So let's talk about tailstock. Tailstock is a main part of lathe machine. In both CNC lathe machine and conventional lathe machine, tailstock is important. The main use of tailstock is to support headstock in order to machine long workpiece. And in this project, we are going to main focus on hand wheel and clamping lever, as these are the main part of tailstock. The main use of hand wheel is to rotate or move tailstock with respect to the lathe bed, and the use of clamping lever is to fix the position of tailstock with respect to the workpiece, or we can say to concentrate the workpiece with respect to headstock and tailstock. So these are the main parts we have to draw in order to assemble. The first one is body, barrel, clamping lever, center, feather key, hand wheel, nut, screw, spindle, spindle bearing, and stud. So this is the final assembly we are going to design. In this design, all other parts are fixed, or we can say fully constrained with respect to the lathe bed. Only the hand wheel and the lever is have given the rotary motion. So as we can see, the hand wheel is rotating, and this is the lever is rotating. Uh, we'll go to the next slide. For the manufacturing, we took spindle bearing, as we have to take the CNC milling machine, but in the tailstock there is no rectangular job. Then also we are going to design manufacturing this spindle bearing. For this manufacturing, we are going to deal with adaptive clearing, countering, boring, drilling, and for the final finishing, we are going to take penciling. From the next one, the Ashish is going to discuss. Thank you.
Hello friends, now let's discuss about the design for manufacturing, or what is called as the DFM. The basic idea behind the DFM is manufacturing the parts or products in simple way with minimum use of material, which reduces the manufacturing time, reduces the usage of material, labor, and machining cost. So for this whole process, we are going to use a ball milling process instead of end milling for manufacturing the parts, which reduces the process time. The cutting angle in ball milling is very high, so the force required is less. Now, about the new design is easy to fabricate because of the use of DFM analysis, and it reduces the number of steps required for providing the number of steps required, also providing the simplicity. In the modified tailstock, an attempt has been made to minimize the sharp edges, burrs, and points wherever possible. So let's discuss about the design for assembly part. The second main thing in manufacturing and assembling part is the design for assembly. Now, design for assembly parts help in ease of assembling the parts. Like manufacturing helps in DFM helps in easing the manufacturing process. DFA helps in easing the assembling process. While assembling the different parts of our assembly, we have taken appropriate diameters of the circular parts. As you can see here, these are all the cylindrical parts that we have manufactured. The main similarity between all these parts is they have been made concentric, so that the assembling of the parts become easy. The main benefit or the main advantage of DFA is that it gives idea about any problem that might occur in future. It gives you idea in the design phase itself, so it allows you to solve any potential problems in the design phase itself, which is less expensive if we compare it to the future problem solving time. The thread dimensions have been kept same for all the subcomponents, which reduces the machining cost again. So this is the redesign of the parts according to the DFM or DFA analysis. As we can see, the lathe body, we have conventional or the old lathe body used to be like this. We have manufactured it to this one, which in which you can see like we have minimized the material usage here, which reduces the machine making production timing of the body, and which also reduces the material requirement. The second part we can see is the hand wheel. The previous hand wheel used to be like this. We have modeled and designed it to be like this. We have added this extra supporting rod, which provides a firmness to the operator, which and a good control over the tailstock while doing any process. So the third part we have redesigned is the clamping lever, although small, but it is of great importance because uh, we have changed the end of the clamping lever to spherical style, so avoids the sharp edges and the safety concern is avoided. Let's see the assembly. This is the assembly here. We can see like the first the body is modeled and it is grounded. The excessive part is reduced with the DFM analysis. Now we can see the different cylindrical parts, those are being assembled here. This bearing, these are all nuts, so these are all made concentric to avoid the assembling time by giving different constraints, so cylindrical constraint is more easy. So this is the assembly final. We can see this wheel. It can be rotated hand wheel. This clamping lever. This helps in fixing the tailstock. To summarize all, we can say that for both the conventional and CNC lathe machine, for proper fixing of the workpiece to support the workpiece on the other half of the lathe machine, we need a tailstock, and it has to be positioned manually. The modified tailstock is as strong as the old one, but it comes with reduced weight and convenient to use. Also, the changes in hand wheel and clamping lever provides extra control, which also helps in distributing the forces uniformly and firmness to the operator while performing any job. So that's it. Thank you.